In a 2014 report, leading capacitor industry expert Dennis Zogby of Pomanock Publications concluded that the unique combination of both high capacitance and high voltage characteristics evident in the eStore capacitor layers are unique and should be considered particularly disruptive to the $6 billion electrolytic segment of the worldwide capacitor industry today. The current eStore layers have many advantages over other capacitors, including eStore has a higher voltage capability. eStore layers demonstrate the same capacitance over a wide range of frequencies. eStore capacitance layers have low comparable costs to produce and are non-toxic. eStore technology allows fast charge and discharge capability. eStore layers have long-term energy storage capabilities.
This is the eStore factory, and we've taken 8.5 years to get this at this shape. It is in production level at the present time. It took $3.5 million, and those in the know that that's fast and very inexpensive for this type of technology. We have 12 patents granted, and I'll point out to you where these patents exist in this factory as we go through it. The first thing we come to on the right is the DI water system. And the reason we installed our own rather than buy one is we need to have something where we have the highest quality water we possibly could get. It's in the neighborhood of 19 megohms resistance. And that water is used in the processing of our chemicals, in the processing of our powders, and throughout the factory. All the things you see here in this factory, eStore Incorporated built here. Like this whole DI water control system was fabricated here, designed here, and tested and put in. Along here in all these tanks, 55-gallon drums I should say, contain our constituents in aqueous form. That's again another major technical breakthrough where our patents identify that, where we've achieved excellent homogeneity of our constituents in an aqueous solution. Each station here has its own localized automation. So on command, this will take powders from these drums up through the system to the next station, which we'll talk about. This is really a filtration system that filters the aqueous solution down to sub-micron level. These powders solutions have been here for, let's say, 5 years with absolutely no degradation at all in the invention that we have. We had to invent the way of putting our constituents into an aqueous solution without them falling out. With that patented process, we now have contained it very solidly in that aqueous solution. And before we make any run, we have an ICP system that I'll have our chemists to define that to you later on, where we quality check this to make sure it's in proper form and hasn't lost any of its constituents. So if we go down through here, we'll see each one of these barrels contain our different constituents that we have in our powders. Powders being barium, calcium, zirconium, titanium, neodymium, manganese, and yttrium. All of these are contained here. At the back here, we'll see a nitrogen farm where all these barrels are back pressured with nitrogen, never sees air, which again assists us in never having degradation. Like I said, these powders have lasted out here for over 5 years with zero degradation. For safety, all of us have had time to come from the integrated circuit world. If we have something that's flammable like isopropyl alcohol or whatever, we have these systems built here where if there's a fire inside of this chamber, this infrared detector up here will detect that fire. It's this level of safety that we have put in this building throughout. So again, whenever you get into these type of factories, safety is first, and this is proof of it here. Now, this is our computer control station for controlling the solutions that go into our powder blending tube that I'll show over here in a minute. And that blending station blends all 7 constituents successfully into that container via automatic controls. These liquid mass flow controllers of there are controlled to put our constituent solutions into this tank automatically through computer control. We had patents for the solutions back there. We have patents for this. We have patents for this system here, showing the manufacturing capability of blending these powders accurately. Again, with the ICP analysis, we take a quality control test of this, make sure that was 100% successful. Now that we got now that we got the powders over here in solution, and I got it tenaciously held, how in the heck am I going to get them broken up to make powders? Well, I tell you, we invented next. We have two solutions back there that, if you blend them properly and you react them in the proper manner in the building of the powders, you can actually form the particles within a millionth of a second. And so, under computer control, automated control, this solution goes up over the roof and into our powder control fabrication factory, along with the two activating chemicals to make the powders automatically. So if you follow me now, this is our powder production cabinet. Inside of this is everything that we use, highly sophisticated, highly proprietary, with multiple patents around it, to produce these powders on demand by automation. Going on down through our production facility, we have to have a way of curing our powders. Now, curing is a very, very important process. We have a patented process, patent equipment that we have for highly proprietary curing. Now, curing means you take the moisture out of the CMPT powders and you shrink them down to the sizes that we want. And when you do that, you get the proper crystal structure that gives us a high permittivity. Now, this room here contains all that equipment, highly proprietary equipment, but over here shows all the automated equipment that we press the button and it automatically goes through the whole CMPT powder curing process. CMPT, composition modified barium titanate powders. So this is production quality.
The eStore composition modified barium titanate, or CMBT powders, allow for the manufacturing of capacitors with the following qualities, as verified in an Intertech report: higher resistance, constant capacitance over wide voltage and frequency ranges, very fast charge and discharge cycles, completely reversible polarity, performance stability when sealed in polypropylene.
This room contains our processing equipment for CMPT powders. You put the powders in here, you press a button, it automatically runs a process for curing the powders, and this oven over here automatically cures the layers. And our chemist over here, with her multiple tasks he does in this building, is actually sputtering metal onto the aluminum layers that we use, and the metal that she's putting is a getter for our particular polymer used, and has a very high adhesion, will never come off. This is the system we use for blending our composition modified barium titanate powder, patented, we call them CMBT powders, into a polymer. Very high intensity blending where we can get the excellent homogeneity of the powders into the polymer solution. We also coat the powders with a proprietary substance at our patent, where it takes the powder coating and ensures that it mixes into the polymer that we have selected. This is our measurement room, where we have different equipment for measuring different parameters on our powders. This happens to be the machine Hariba, which measures the particle size very accurately. It's a standard of the industry for doing that particular application. If you take a look at this paper here, this paper shows that the particles are of a very narrow distribution, about 0.4 microns to 1.1 microns, and very narrow distribution. This is our quality control check of that process to ensure our powders meet the permittivity that we're looking for.
This is an ICP system by Perkin-Elmer. It's a mass spectrometer. ICP stands for inductively coupled plasma. It uses a very hot plasma to take a large molecule and separate it into its atomic elements. And then the mass spectrometer detects each element by its different mass. In the end, what we can do is determine the concentration of what's in our barrels that we keep out in the warehouse. We want to keep quality control on that for every batch that we make of our powders. But we quality control that and analyze before they go into the powders. And then again, after the powder is made, I run the system again just to make sure that every element that we told to go in is in. So we want about 99% or higher homogeneity.
This part of our production process is a anti-agglomeration system that we bought, put the equipment here, installed it here. When you take these CMD powders and you cure them through the curing process that we'll have showed you here, and we'll be showing you more of it, they agglomerate a little bit. That means they stick together a little bit, and we have to have a way to break that up. And when we break it up, we take in the Hariba system that I showed you. It shows the accuracy, what we've got for quality control on the distribution. This system gives that to me. Now the system right next to it here is our spin coating system with one of our engineers who runs that system. We're going to put a layer onto it. He'll vacuum chuck that down. After vacuum chucking it, and this whole system here is automated. You push a button and it automatically makes these layers, and we have it so precisely made to give the layer thickness extreme accuracy so we get the capacitance that we're looking for. This system can be expanded to a much larger system and put with high throughput for production, but this is a production model right here that can actually build capacity. It is production. This is our dry box, and in this system here, we keep the air at 5% relative humidity. That's so when we get the parts coming out of our vacuum box over, we stack our layers in there, about 30 of them, dry them out so they're super dry. The reason that you take the water out, the insulation resistance goes up to the high, say 20, 30 gig ohm range or even better. That gives us a better capacitor, a better time constant, and it improves our system for being competitive in the capacitor world. Now he's initializing the robot itself. Now it's going to pick up the first layer. See how it successfully picked up that layer and very accurately picked it up. That's the accuracy of this system. Now it's going to come over and put it down. Then these robots come into play to hold it there as it comes down and puts it in for its first layering process. Now it's going to pick up the second layer and accurately lay it down so we have the accuracy to allow us to get the high voltages. You see it very accurately placed the second layer down. Now the outside robots are going to go reach over and hold that down while they're ready themselves for the Mylar insulation layer to come over. Here it goes. Now it's going to go over and pick up the insulation layer. Now lay this layer down, and both our layers will hold that in position while we'll put a technique we've got to bond these layers together before we move it back in here for injected molding. We also have a patent pending on this action here also. And we needed that accuracy to ensure that we're going to get the voltage that we're looking for, and those robots were put on that plate by my team. I designed and actually built the plates in there, but Kevin Sod, one of our engineers here, put the stuff onto that plate very accurately so that when we go through the programming, it can find those parts extremely precise and put them in the spots that we want. Each one of the steps that we've seen today going through the factory took time because these are production level steps. When I was invested by a client person called from the buyer says, Dick, we don't want an R&D shop, we want a production shop with have the first level controls in there as soon as possible. It'll take you longer, but when you get there, you'll see the rewards of it, and that's what we're seeing now. Yes, we do have a production shop, and also it's expandable. Here is where we do the testing in all of our layers for leakage current, insulation resistance, and capacitance. I designed this whole system, put it together, and we've had this certified by a PhD metrologist out of the University of Texas. And Intertech came here and we showed them this system. They looked at it. They said, this sounds got some good things to it. They went home and designed their own system, and their data corresponds to our data, which is another high level of certification of the process I'm going to show you. This is one of our test parts. Let's go in here, and with this, I'll show you how we test this. This is our test area. I invented this room here to get a very accurate measurement of our insulation resistance. It was extremely important in this capacitor business. The next thing is the leakage current, along with a very accurate measurement of our capacitance. This whole system here is based on an RC time constant, which can be extremely accurate if you know what your parameters are. Well, in this thing, we know what the voltage is by a very precision power supply. We also know that the resistance that we're using for the discharge resistor has been certified by a metrologist from the University of Texas, along with Intertech. Intertech came over here and built a system that they understood it. They went home and built their own system and certified their data to be accurate to ours. So we have highly certification of this design. I'm getting 0.0149 microfarads, and that's only 6 layers on a small capacitor. That's state of the art. So that is prototype layer, and what we're making, what we saw today, that will be production level layers that we'll be certifying and handing it out to customers as they come through. So this is our system. Again, we designed it here, invented it here, and it works and certified. Thank you ever so much.
eStore's technical achievements are protected by 12 granted patents. Thank you for your interest in eStore.